The night sky, full of countless stars, has always been a source of wonder and mystery. For centuries, man has searched and searched for answers to the basic questions of existence. When the James Webb Space Telescope, JWST, was launched, it promised to reveal secrets that had eluded us for millennia. A monumental astronomical achievement, initially anticipated with great hopes, soon became the center of a scientific revolution. Former NASA Science Director Thomas Kin eloquently captured the JWST handover. He noted, "The launch of JWST marks the beginning of a new era of stargazing. Webb will expand and challenge our cosmology and understanding of planets at the beginning of life." His words found a deep resonance both in the scientific community and elsewhere. The anticipation was palpable. JWST was expected to change our understanding of the universe. What began as optimism and ambition soon turned into a storm of controversy and confusion. JWST's unexpected findings stunned scientists and shook the foundations of cosmology. The telescope's unparalleled capabilities yielded revelations that seemed to contradict long-held theories about the age, structure, and origin of the universe. Academia was in an uproar. Could these disturbing observations be about to get worse? Or will they finally usher in a new era of understanding physics? As the debate continued, the main question remained. Have scientists really solved the mysteries surrounding JWST's elusive revelations? Or have they merely offered shaky explanations to save time? The $11 billion JWST project inadvertently brought cosmology into a major crisis. This reversal in space-related natural sciences resembled the seismic shift from geocentrism to heliocentrism in the Middle Ages. It seemed that we had to face the uncomfortable truth that the foundations of modern physics are incomplete and that our understanding of the universe is far from complete. Modern astronomy, the study of the physical characteristics and relationships of the universe, is strongly based on principles that come from classical antiquity and the Middle Ages, especially Sir Isaac Newton. The first observations of ancient mechanics and the elements, followed by Newton's discovery of gravity, laid the foundation for our scientific understanding of the universe. These principles, which extended from Earth to space, produced consistent results for some time. But as our view of the universe expanded, these known quantities were no longer sufficient to describe what we observed. The crisis began when different methods for measuring the age and expansion of the universe produced inconsistent results. Local measurements based on galactic objects conflicted with measurements of the cosmic microwave background of the early universe. This disagreement, known as the Hubble tension, highlighted a fundamental inconsistency. In the center of this debate was the Hubble constant, which indicates the speed with which the universe expands. In the summer of 2022, JWST's discovery of many old and complex galaxies raised important questions about our understanding of the age of the universe. According to current physics, the universe is approximately 13.8 billion years old. However, JWST detected galaxies that appeared to have fully formed only 200 to 300 million years after the Big Bang. This seemed impossible because our models showed that galaxies took billions of years to form. The impact was profound. If these galaxies existed so soon after the Big Bang, it meant that our understanding of the timeline of the universe was fundamentally flawed. The idea that the universe began with the Big Bang 13.8 billion years ago and has been expanding since then, undergoing a slow evolution of matter, cannot be entirely correct. We found ourselves at a crossroads. Either we were wrong to assume that our everyday physics is universally applicable, or we discovered only a small part of the real physics that governs the cosmos. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." This proverb suggested that the physics present in the universe should also exist on Earth. However, perhaps we have overlooked those forces and aspects on our planet that have now manifested in space. JWST's abilities were quite extraordinary. Its 18-tiled mirrors were able to detect incredibly weak light signals and capture light that has traveled through the universe for more than 13 billion years. An extraordinary exposure technique made these faint traces visible for the first time. This revolutionary technique allowed us to see light from the most distant galaxies that formed shortly after the Big Bang in the summer of 2022. These discoveries were both spectacular and depressing. Instead of observing infant galaxies, JWST revealed perfectly formed galaxies that appeared to be several billion years old. Since the age of the universe is 13.5 to 13.6 billion years, this seemed impossible. Scientists today sometimes describe objects and images taken by JWST as incomprehensible or inauthentic anomalies. There must be a comprehensive framework, and scientists are diligently searching for its size, number, and patterns. Former NASA chief scientist David Adams described the launch of JWST as an epic breakthrough in our understanding of the universe. He noted, "It promises to push the boundaries of our knowledge about the origins of the universe, planets, and life." However, what started with great expectations soon became a great controversy. The unexpected findings of JWST shocked the academic community and led to debates about the future of cosmology. The question remained, will this mess get worse, or will new physical discoveries and debates finally find a solution? Have scientists really solved the mysteries of JWST's ongoing announcements, or have we not been given enough explanations? Originally designed to bring clarity, JWST instead confused cosmology. All aspects of space-related science underwent a seismic shift similar to the shift in worldview from geocentrism to heliocentrism in the Middle Ages. We may have to admit that the foundations of modern physics are flawed, and that our interpretation of the universe is fundamentally flawed. How did this happen? Modern astronomy, the study of the physical characteristics and relationships of the universe, is based on principles that come from ancient researchers, the Middle Ages, and most prominently Sir Isaac Newton. Ancient observations introduced the original concepts of mechanics and the elements, and Newton later defined gravity, which is crucial to astronomy. These principles supported our scientific understanding of the universe by extending the known quantities and forces of the Earth into space with consistent results. But as our visible universe expanded, these detected quantities no longer described what we observed.
This situation resulted from conflicting results obtained by different methods of measuring the age and expansion rate of the universe. Local measurements based on galactic objects conflicted with measurements of the cosmic microwave background of the early universe. We know this difference as the Hubble tension, and the Hubble constant represents the rate at which the universe is expanding in the summer of 2022. When JWST discovered so many old and deeply formed systems in space, questions arose about how to determine the age of the universe. Our universe can hardly be 13.8 billion years old when, thanks to JWST, we can see that galaxies were already formed 200 to 300 million years after the Big Bang. According to current physics, universes take billions of years to form. For the systems found by JWST, this would mean that their time of organization was before the Big Bang. Our old cosmology, which states that the universe began with the Big Bang 13.8 billion years ago and then expanded through the slow evolution of matter, cannot be correct. We are at a crossroads. It is possible that we make the mistake of assuming that our natural physics can be applied to the entire universe, or that we have discovered only a small fraction of the physics that actually exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this saying, all the physics of the universe should also be found on the planet. However, we may have overlooked the strengths and aspects of our planet that we now see in space. JWST breaks all records. Its ability to detect incredibly weak light signals is amazing. Webb's 18-tile mirrors capture light that has traveled through the universe for more than 13 billion years. An exceptional exposure technique makes these faint traces visible for the first time. Thanks to this revolutionary technology, we saw light from the most distant galaxies that formed right after the Big Bang in the summer of 2022. These galaxies were both spectacular and disappointing. Instead of small galaxies, JWST shows perfectly formed galaxies that appear to be several billion years old. But at 13.5 or 13.6 billion years, that could never be the case. Scientists today sometimes say that objects and images are incomprehensible or not true specialties. There must be something like a basic frame, and our researchers are looking for sizes, numbers, and models for it. Former NASA chief scientist Adams' statement about the JWST launch was prophetic. He said, "The messenger of the James Webb Space Telescope is a groundbreaking epic in our understanding of the universe. It promises to push the boundaries of our knowledge about the origins of the universe, the planets, and life itself." What started with high hopes turned into a major controversy. JWST's unexpected findings shocked the academic community. The disruption caused by the JWST findings has sparked heated debate. Will this mess get worse, or will new discoveries and physics controversies finally find a solution? What does that really mean? Have scientists really solved the mysteries of the ongoing JWST announcements, or are we lulled with inadequate explanations? The $11 billion project, originally intended to bring clarity, instead confused cosmology.